हेलो स्टूडेंट्स, हाउ आर यू ऑल? कैसे हैं आप सब लोग? हाउ आर यू गाइस? उमंग कुमार पटेल, इट्स बीन स्टार्टेड नाउ. Great. So I am here. I'm sorry I became 2 or 3 minutes late because of some issue in setup. I hope I am audible. Yes, great. So dear, in the last class I had discussed about something called as ASA tool signature, right? And I told you that ASA tool signature is based on machine reference system. Yes. Today we are starting with the another type of tool signature system, that is called as ORS tool signature system. Yes. Good evening. Good evening to all of you. Good evening to all of you. Umang Kumar waited for 2 days. For why did you wait for 2 days, Umang? What happened that you had to wait for 2 days? 2 consecutive days? Chalo. You see, let me first write you this ORS tool signature, and then I will tell you what exactly is this and why is it this. That also I will tell you, and believe me, this is the first time in your life that you are going to understand what is ORS tool signature, what are the angles, how exactly they look like, what is the use of ORS tool signature. Instead we have ASA tool signature. Everything you are going to understand first time in your life, believe me. Yes, stay in the class, that's most important. Yes students, as I told you earlier, whatever kind of tool signature system, the number of components will be 7. Similarly, in ORS tool signature, the number of components will be 7. Like let us say 7 degree, 6 degree, 9 degree, 4 degree, 12 degree, 75 degree, and let us say 1 mm. You know, in ORS tool signature, I'm sorry. You know, in ORS tool signature, the name of the first angle, do you know that? The first angle name is actually inclination angle, and we will denote it by I, inclination angle. The second angle at the second position, do you know the name? This is called as orthogonal rake angle. And then here, the third position angle is what we call as side relief angle of NRS system. Then the fourth angle is what we call as end relief angle of NRS system. The fifth angle is what we call as end cutting edge angle of NRS system, and the sixth one is what we call as principal cutting edge angle, and then this 1 mm is nothing but your nose radius. The most important thing is how will you remember this sequence. First thing is that this sequence needs to be remembered. 7 degree, that is inclination angle, 6 degree, that is orthogonal rake angle, gamma sm, that is side relief angle, side cut end relief angle, end cutting edge angle, lambda is principal cutting edge angle. Let me name it. Few angles you should remember the name. I for inclination angle, then alpha naught is your orthogonal rake angle, and this angle is the most important angle in metal cutting apart from inclination angle, and this lambda is the principal cutting edge angle. Whole metal cutting, my dear, force analysis is based on only these three angles. Yes, whole metal cutting analysis is based on only three angles. These three angles, my dear students, these three angles. What are those angles? Look at this once again. Inclination angle, orthogonal angle, side relief angle, end relief angle, end cutting edge angle, principal cutting edge angle, lambda, principal cutting edge angle, and 1 mm, that is the nose radius. Okay, now listen carefully. How will you remember this sequence? This you have to remember like this. You studied grammar in your school days, and there you studied like some tenses. Tense you studied, na? And in tense you studied the first tense, that was the present tense. And in that present tense you studied the first, that classification one, simple present, and then you form the sentence like subject plus verb plus object, like you subject, see verb, him object. Yes, you see him is a sentence of simple present tense. Similarly, we are going to form a sentence of simple present tense. Similarly, we are going to form a sentence of simple present tense, and it is subject is I alpha O, C lambda N. This is the patented trick of Rajeev Singh. Yes, patented by Rajeev Singh. I alpha O, C lambda N. I for inclination angle, alpha O for orthogonal angle, S for, now you see, I for you will easily remember. First you remember this sentence, I alpha O C lambda N, I alpha O C lambda N, I alpha O C lambda N, and thereafter I for inclination angle, alpha O for orthogonal angle. Now the story comes. I told you yesterday, first you give relief or you do the cutting. First you give the relief, and relief is given like for a month, and then cutting is done at once, right? I told you the story of Bakara. I told you the story of capital punishment, सजाए मौत. 7 दिन 10 दिन तक उसको खूब रिलीफ देते हैं और फिर उसको फांसी पे चढ़ाते हैं, करते हैं ना. पूरा रिलीफ देना है पहले. तो फर्स्ट कम्स रिलीफ. सो दिस first part here, these two angles will go for relief, and then this one will go for cutting. Believe me, if you don't understand the angles of ORS, you cannot do the force analysis. If you are doing, you are just playing with BrahMos nuclear weapons. This is your principal cutting edge angle, undoubtedly. So now it becomes very easy to remember. I alpha C lambda N, I alpha C lambda N, I for inclination angle, alpha for orthogonal angle, S for side relief angle, E for end relief angle, E for end cutting edge angle, and then lambda for principal cutting edge angle. You understood this. This is the sequence. Now I am telling you one thing. People say, and it is said that this ORS tool signature is based on tool reference system. AS signature was based on machine reference system. ORS tool signature is based on, people say that, tool reference system. Yes, I am seeing your chats as well at the same time, and I am seeing myself as well, that everything is going good. You see, why was it is being told like AS is based on machine reference system? Because the angles of the face, the flanks were being measured either with respect to the planes which were of machine or into the planes which were of machine. But there is a problem with ASA tool signature. What is the problem? That let me show you. Be very conscious and very careful, because this is the first time in your life that you are going to know this fact. Yes, you see, let me roughly draw a tool. This is your tool, right, my dear? I hope you are able to see. Yes, I am just drawing it roughly, but it's looking quite good. Now we have certain planes. Let me show you the planes now. Here, this axis is your z axis, and then we have this another axis. Let us say this one. This is like, sorry, just a minute, let me undo it. Yes, we have another axis. This is your x axis, and let me choose one more axis, that is going to be your y axis. This is your y axis, or let me again undo it. Yes, here let us say your y axis. These three axes are of machine and the planes are there. You see, I'll show you the planes. Here there is this plane. I am drawing roughly, but still you will understand, don't worry. This is a plane. Yesterday I told you, what plane is that? Pi y, the transverse plane, and we have another plane here, this red color one, and let me show you that red color plane, and this is here, this plane. What plane is that? This is your pi x plane. Great, dear. And now we have the reference plane here as well. Where is the reference plane? Let me show you the color. That reference plane is here. Let me show this to you with this color. This is the another plane we have. Yes. What plane is that? This plane is the reference plane. What plane is that? This plane is the reference plane. Yesterday only I told you, dear students, that, let me see whether this is visible to you or not. Yes, nicely visible. This angle here, I told you, is the back rake angle, because it shows the backward slope of the rake face, and this angle here is your side rake angle, as it shows the sideward slope of the rake face. Now stay here. This is the planes of ASA. This is the machine reference system, back rake angle, side rake angle. Okay. Now, as you are machining the workpiece, you know, now let me show you first the angles of ORS. I have here shown you the angles of ASA, the first two angles, back rake angle and side rake angle. Now, my dear students, let me show you, but green color is visible to me here in my phone. I don't know why it is not visible to you in your phone. You see, green color is visible to me in my phone. I can also see, na? But okay, I'll take care from the next time that I don't use this green color. Fine. Okay, Subham, I'll take care. Come on, man. So now, this is a very important concept that I am going to discuss. So be very much careful, be very sincere in the class. Look at this, what I am going to tell you. Here, in the ORS tool signature, which is said that it is based on tool reference system, the planes will not be of machine. Now the planes will be of tools. Now let me show you what are the planes of the tool. You know, if this is a tool, my dear student, if this is the tool, look at this very carefully. It may take a bit of time, but once you learn this, metal cutting will become like a, play for you. Very simple. Now, if you are machining a workpiece, then you know that during the machining of workpiece, where are the forces going to appear? That forces, where will you observe them? This is the cutting edge. The workpiece is rotating, so the forces that you will observe will be acting undoubtedly along this cutting edge. Yes, the forces will be acting along this cutting edge. Undoubtedly, the workpiece will force the tool in the downward direction. So the tool will force the workpiece in the upward direction, isn't it? I hope you are understanding. Yes, workpiece is rotating and forcing the tool downwards. So the tool will force the workpiece upwards, and here there will be this force, and this force will act in a plane which is exactly along the cutting edge, isn't it? Yes, during machining, the forces will act exactly along the cutting edge. Means these forces will act undoubtedly in a plane which is exactly along the cutting edge. This plane, and then since there is a contact, look at this very carefully. Since there is a contact between the tool and the workpiece, so there will be a contact force, and contact force always acts in a direction perpendicular to the cutting edge. So this force, which is like acting perpendicular to the cutting edge, will be in a plane which is exactly perpendicular to the cutting edge. But if you look at the ASA system of tool signature, then if you look at pi y plane and if you look at pi x plane, this plane is here your pi x plane. Yes, if you look at pi x and pi y plane, do you think that these planes are either along the cutting edge or in a direction perpendicular to the cutting edge? मेरा phone off हो गया. Huh? Do you think that these forces are either along the cutting edge or perpendicular to the cutting edge? No, my dear students. No, these planes are neither along the cutting edge nor perpendicular to the cutting edge. The red color plane and the cutting edge here, black color, this angle from here to there is more than 90 degree. Yes, not perpendicular. The cutting edge is here, right? And the plane is passing like this. So the plane is not along the cutting edge. But right now we discussed, if machining is happening, then forces will appear in the planes which are either along the cutting edge or in the planes which are perpendicular to the cutting edge. So my dear students, believe me, listen to me carefully. If the force analysis has to be done, then my dear, can you use during the force analysis, can you use, my dear, the angles being measured into these planes? For the force analysis, can you use back rake angle and side rake angle? No, you cannot use back rake angle and side rake angle for the analysis of force. Why? Because back rake angle and side rake angle are the angles which are measured in a plane or in the planes pi y or pi x, which are neither along the cutting edge nor perpendicular to the cutting edge, but the forces which are there, cutting force and thrust force, they will appear in the planes which are exactly along the cutting edge or which are exactly perpendicular to the cutting edge, right? But here none of the planes are exactly along the cutting edge nor perpendicular to the cutting edge. So these angles which we are measuring in those planes cannot be used for force analysis. So for the purpose of force analysis, what we did, we introduced ORS tool signature. I'm sorry, for what purpose? I'm just coming live on YouTube, even I can watch that what you are commenting with the help of like my laptop, because my phone has switched off. Give me a minute, huh? I'll just come live. Just a minute. Hold on, dear students, huh? So that I can see what is going on there in the chat section. That is also necessary to know. If you don't understand something, I can come back to you and I can explain that to you. Yes, let me also go live on my laptop so that I can watch my lecture along with you. Yes, now I saw it. But whenever we start a lecture, at first this ad comes, right? Chalo, now great, I can see you. But the chat is coming. Yes, come on. मोना जोशी सिंह, जय बिहार। अरे बोलो जय भारत माता की जय। भाई और बहनों, भारत माता की। अरे बोलो चैट सेक्शन में, भाई और बहनों, भारत माता की। चलो, मोना कह रही है जय बिहार। कम ऑन हियर, लुक एट दिस concept, this concept that I have just discussed. What is the need of ORS? Believe me, you go to any coaching center or you go to any teacher in whole India or whole world or universe, no one will explain you what is the need of ORS tool signature. And yes, believe me, no one will tell you what is inclination angle and what is orthogonal angle. For the first time in the history of YouTube and for the first time in the history of whole universe, you are going to see what is inclination angle, what is orthogonal angle, and what are their need. ORS tool signature, why is it needed? Because in ASA tool signature, the planes like this plane, pi y plane, this plane, pi y plane, vertical one, pi y plane, and this plane pi x that I discussed yesterday, are neither along the cutting edge nor perpendicular to the cutting edge. But my dear students, when you look at the forces which are appearing during the machining operation, then how will the forces appear? You see, I'll show you. This is how the forces will appear. This is a workpiece and this is your tool, my dear. Yes, the tool is machining the workpiece. How the tool is machining the workpiece? This is how the tool is machining the workpiece. Look at this. This workpiece is rotating. As the workpiece is rotating, it is forcing the cutting edge in the downward direction. So the cutting edge is forcing the workpiece in the upward direction. Cutting edge is forcing the workpiece in the upward direction. Cutting edge is forcing the workpiece in the upward direction like this. Yes. Cutting edge is forcing the workpiece in the upward direction like this. So this is one of the force, cutting force actually. And then you are giving the feed to the tool. There is a contact between the cutting tool and workpiece right here. Yes, there is a contact between cutting tool and workpiece. So if contact is there, my dear, there must be a contact force. And that contact force which will be there, that contact force, my dear students, which will be there, that must be perpendicular to the contact zone. And if it is perpendicular to the cutting zone, this force will act like this. Yes. Now listen to me. These forces are appearing, in which planes? In these planes. I will show you. These are the planes in which these forces are appearing. You see? These are the planes in which these forces are appearing. Look at this. This is one of the plane in which what force is appearing? Workpiece is rotating, so it is forcing the cutting edge downwards. So cutting edge is forcing the workpiece in the upward direction. That is the cutting force which is appearing in this plane, which is exactly along the cutting edge. Now look at the previous system. Look at the previous system. Look at this. This plane here is a pi y plane of machine reference system, ASA system. But my dear students, look at this plane. This plane is entirely different as compared to this plane pi y here. This plane pi y here. Why? Because pi y is not along the cutting edge. Here cutting edge is there. This is the cutting edge, right? This is the cutting edge from there to here. But this plane which I have shown you here is not along the cutting edge. Yes? But this is pi y plane. Look at the next ORS system plane. ORS system plane. Here it is. Look at this plane. This plane is exactly along the cutting edge, and this is the plane in which the force will appear in the upward direction in the same plane. And you know, that is why, since in this plane cutting force will appear, that is why this plane is called as cutting plane. Pi c is the cutting plane, and this plane is not of the machine. This plane is exactly along the cutting edge of the tool. So this plane is of tool. Now there is another plane. Just perpendicular to the cutting edge. Just perpendicular to the cutting edge. This plane is perpendicular to the cutting edge. You know, since this plane is perpendicular to the cutting edge, this plane is called as orthogonal plane. What plane is this? Orthogonal plane. Did you understand what is cutting plane, what is orthogonal plane? Okay, and these two planes are, you know, different as compared to the planes of ASA tool signature, which is based on machine reference system. Yes, my dear students. Now listen to me very carefully. There was another plane here in machine reference system, this green color plane, pi r, reference plane, parallel to the base of the tool. Now dear student, look at this. A similar plane will be there, or the same plane will be there, reference plane here also in this system as well. Here also in this system as well. This is that plane. This is that plane. You know, this plane is the reference plane. This is common to both the system. This is common to both the system, ASA system and ORS system, the reference plane. Okay, dear students. Now, when you were measuring the angles of this tool different surfaces with respect to or in the planes of the machine which are pi x and pi y and pi r, you were saying that these are the angles of ASA system based on machine reference system. The first two angles were back rake angle and side rake angle. Back rake angle shows you the backward inclination of the rake face. Side rake angle shows you the sideward inclination of the rake face. Can you use these angles for the analysis of force? No. Why can't you use these angles for the analysis of force? The reason is, my dear student, the planes, this blue color and this red color, this pi y and this pi x, in which back rake angle in pi y and side rake angle in pi x are being measured, these planes are neither along the cutting edge nor perpendicular to the cutting edge, but the forces appear in the planes which are exactly along the cutting edge or perpendicular to the cutting edge. Yes. So how can you use this back rake angle and side rake angle for force analysis? There came the need of the system in which the planes are as such which are exactly along the cutting edge or perpendicular to the cutting edge. And that is the system which I have shown you here. And this is what called as tool reference system. This is what we call as tool reference system. Now, my dear students, from all of you, I need one answer in the chat box that for the force analysis, you will use ASA tool signature angles or ORS tool signature angles. You tell me, dear. You will use the angles of ASA tool signature or ORS tool signature. Tell me, dear students, in the chat box. I am waiting for you. Come on, man. ASA tool signature यूज करोगे या ORS tool signature यूज करोगे? Yes, very nice, Umang Kumar Patel. We will be using ORS tool signature. Great, dear, great. देखो, if you are getting any problem in understanding the concepts, you can always tell me. But if you are really feeling like, yes, something good is happening, something best is being provided to you, right? Good concepts are being given to you. One of my requests is there. Let others know. Let others know that, these concepts are even being discussed, which was not discussed ever before. Not on YouTube, not in any coaching class. And these are the most important concepts. Without this, you cannot do anything in metal cutting. Yes. Now, I will tell you about the first two angles of ORS tool signature, which are very important. The first one is inclination angle and the second one is orthogonal rake angle. Look at what are those angles. Just stay with me. Just stay with me. Let me show you. You will have to be very much attentive in the class, very much conscious in the class, then only you will understand. Otherwise, you will not. Be very much attentive, very much cautious in this class. Whatever I am going to discuss, let me tell you, not very easy, but yes, if you stay conscious, I will make it very easy for you. There is this axis, let us say Z axis, and then we have a plane here exactly along the cutting edge. I have just introduced this plane to you in the last slide, and yes, you came to know that this plane is nothing but your cutting plane. Yes, dear student, this plane is your cutting plane. It is exactly along the cutting edge. Now, there is going to be a reference plane as well. There is going to be a reference plane as well. Let me show you the reference plane. Just hold on. Let me show you the reference plane. Here it is, the reference plane. I need some straight lines. Just a minute. I'll draw the straight lines. Hold on. Let me take the shapes. Then only if the diagram is beautiful, you will understand. Otherwise, you might get some problem as well. Okay. Just a minute. Where is the shapes? Okay. This became same color, na? Let me change the color as well. Hold on. I mistakenly did not change the color, but now I will do. Let me take this color. This line. Yes. This is the reference point. I hope you understand what plane is exactly this. Just a minute. Huh? I hope you understood about what plane exactly is this. Yes, this is your reference plane. Beautiful. It takes some time to show the beauties, but once you show the beauty, once you see the beauty, this whole metal cutting will become really beautiful for you. You know, this is your reference plane. This is your reference plane. This is your reference plane. Yes. And right now I have drawn this plane. What plane exactly is that? You all know that this plane is the cutting plane, pi c. This rake face is having how many slopes? How many inclinations? It has two slopes. One in this direction, that is backward slope. One in another direction, that is sideward slope. Backward slope, sideward slope. You see, in the ASA tool signature system, what were we doing? We were measuring this back rake angle, backward inclination with respect to reference plane, but in what plane? But in the cutting plane we were measuring that. Yes. Again we are going to do the measurement, that is the backward slope of the rake face with respect to reference plane only, but now you measure this angle. In which plane? In the cutting plane, which is exactly along the cutting edge. This angle you look at now. Look at this angle now. Look at this angle. Do you think that this angle, undoubtedly, this is being measured with respect to reference plane only, and it is being measured in the backward direction only? Yes. But my dear student, this is no more being measured in the pi y plane. Now it is being measured in which plane? Now it is being measured in the pi c plane. Right? That will be there some angle. That angle is what, my dear students, there is another plane here. Let me draw this another plane as well, so that this diagram looks perfectly three-dimensional to all of you. So that this looks perfectly three-dimensional to all of you. Yes, let me draw this plane. This plane is the plane which is perpendicular to the cutting edge, and this is called as orthogonal plane. Okay, I'll come to this plane later on. Just stay with me. Let us first try to understand this angle. This angle that you have just seen here, this angle is from the reference plane up to the rake face, but it is now being measured in which plane? It is now being measured not in pi y, it is now being measured in pi c plane, and you know this angle is what we call as inclination angle. This angle is what we call as inclination angle, my dear students. Do you think that the inclination angle and back rake angle will be equal, or will they be different? I want your answer in the chat section. इंक्लिनेशन एंगल और बैक रेक एंगल मैं फिर से दिखा देता हूं, देख लो यहां पे, ये तुम्हारा बैक रेक एंगल है यहां से यहां तक. यस. और अब दूसरे डायग्राम को देखो, टूल रेफरेंस सिस्टम ओआरएस को देखो, ये तुम्हारा इंक्लिनेशन एंगल है यहां से यहां तक. क्या लगता है बैक रेक एंगल और इंक्लिनेशन एंगल बराबर होंगे, या फिर अगर बराबर नहीं होंगे तो अभी इस केस में जो मैंने टूल दिखाया है, कौन सा एंगल बड़ा होगा, कौन सा एंगल छोटा होगा? देखो इजी नहीं है, बट इससे बेहतर तरीका नहीं है समझने का. एनीवन हु कैन आंसर मी इन द चैट सेक्शन, व्हिच वन विल बी स्मॉलर, which one will be large? No Sri Ram Kendre, both of them will be different. I'll show you. Just a minute, hold on. Tool. Yes. I'm just doing it rough so that you understand and we make it fast, okay? But choosing color is bit, difficult task. But anyhow, Z-axis. Tell me what plane is this? Tell me guys, what plane is this in the comment section? Chat sections should keep working. Yes. What plane is this, dear students? What plane is this? Tell me, dear. Cutting plane. Yes, awesome, Divakar Sharma. This is the cutting plane. And what plane is that? Let me show you. ये वाला प्लेन बताओ, ये कौन सा प्लेन है? What plane is this? अभी रेड कलर का है, उसके पीछे एक और प्लेन है. ये वाला तो तुमने बोला ठीक है. This plane is your cutting plane, pi c, and this red color plane is what? Pi y. Yes. What am I asking from all of you? What am I asking from all of you is where is the reference plane? Let me show you the reference plane to you as well. Then it will be further more clear to all of you. Let me show you the reference plane as well. Then it will be further more clear to you. You will understand it very well if I show you the reference plane. You see, this is the reference plane, right? Pi r extending here as well. Pi r. I am just drawing roughly. Now, from reference plane, look at this very carefully. This black color plane, I think you are able to visualize, na? That black color plane is the reference plane. Yes, you are able to visualize. Yes. So if you look at this, just a minute. I am also watching what is going on. So from this reference plane, you see, this is the reference plane here. You measure the backward slope of rake face, but you measure it into this red color plane at the front side, this plane. Then you will like start from here and you will measure it up to this. Yes, I am doing like undo. Let me take the reference plane in some other color. I think it will confuse you because everything is becoming black. Let me take the reference plane in some other color and let me choose the color like deep green. This is like your reference plane. Yes, this is like your reference plane, that you understand. Yes. Now from the reference plane you measure the backward slope. Then that backward slope is from here up to this, na? And this is the back rake angle. And from the same reference plane you measure the backward inclination only, but you don't measure this in pi y. You measure this in the plane behind pi y, that is pi c, which is exactly along the cutting edge. Then the measurement will end here only, and this will be called as inclination angle. Now if I am saying you that this back rake angle is equal to 10 degree, this measurement that you are getting is 10 degree, let us say, then what about this measurement in pi c plane? That will be less than 10 degree or more than 10 degree. Look at the diagram very carefully and now tell me. Look at the diagram very carefully and now tell me. Look at the diagram very carefully and tell me. Divakar Sharma is telling more than 10. Oh my God. Divakar, it will not be more than 10. यू सी, देखो तो तुम यहां से यहां तक चलो, कितना किलोमीटर चले? 10 किलोमीटर। अच्छा, और तुम वहीं से चलो, रेट फेस पे ही पहुंचो, लेकिन ये सामने वाले प्लेन में मत चलो, पीछे वाले प्लेन में चलो, तो क्या तुम 10 किलोमीटर से ज्यादा ट्रेवल करोगे दिवाकर? देखो तो साफ साफ दिख रहा है कि वो 10 किलोमीटर से कम है, और साफ साफ नहीं दिख रहा है तो मैं आज दिखा के ही दम लूंगा। रुक जाओ। रेट फेस, मान लो ये जो रेट फेस है ना, वो ये है, ठीक। इसके कितने स्लोप हैं इस रेट फेस के? एक बैकवर्ड है और एक साइडवर्ड है। दो स्लोप है ना, एक बैकवर्ड है, एक स्लोप बैकवर्ड है, एक साइडवर्ड है। हम लोग कौन सा स्लोप मेजर कर रहे हैं? व्हाट स्लोप आर वी मेजरिंग? बैकवर्ड स्लोप। अब सुनो जरा ध्यान से, तुम ध्यान से सुनो। मेरे को कुछ और प्लेन्स लेने होंगे, पता नहीं कहां से प्लेन उठाऊं मैं। चलो मिला एक प्लेन। रेफरेंस प्लेन कहां है? ये रेफरेंस प्लेन है ना। मान लो कि रेफरेंस प्लेन इज अ लाइन, राइट? लेट अस से रेफरेंस प्लेन इज अ लाइन। सामने से जो लाइन दिख रहा है, कौन सा लाइन? ये वाला, यहां से यहां तक जो लाइन है, रेफरेंस प्लेन है, ठीक है। ये रेट फेस है। रेट फेस का बैकवर्ड स्लोप है, बैकवर्ड स्लोप, साइडवर्ड स्लोप, दो स्लोप है रेट फेस के, दो स्लोप, बैकवर्ड, साइडवर्ड। दिस इज योर रेफरेंस प्लेन। तो सामने से देखोगे तो ये तो सीधा लाइन की तरह दिखेगा ना, दिस विल लुक लाइक अ लाइन ना। यस, सो ध्यान में रखो कि यहाँ एक हॉरिजॉन्टल लाइन है। नाउ कटिंग प्लेन कहाँ है? कटिंग प्लेन एग्जैक्टली इस कटिंग एज के अलोंग है, यहां पे है, यहां पे है आपका कटिंग प्लेन। देखो, दिस इज योर कटिंग प्लेन एंड पाई वाई क्या है? क्या कटिंग एज के अलोंग है क्या? नहीं, पाई वाई इधर ऐसा है ना, ऐसा आया है पाई वाई, तो ये आपका पाई वाई प्लेन है। अब तुम ध्यान से देखो, एक प्लेन यहां है, यहां पे तुम हॉरिजॉन्टल लाइन को ड्रॉ करो। जस्ट अ मिनट, सेटअप गिर गया, होल्ड ऑन। ये रेट फेस, रेफरेंस प्लेन एक लाइन मान लो हॉरिजॉन्टल, और ये वाला प्लेन जो है, दिस इज योर पाई वाई, राइट? अब देखो ध्यान से, रेफरेंस प्लेन एक लाइन वहां सोच लो, वो लाइन यहां से ऐसे गुजरेगा सीधा हॉरिजॉन्टल, वहां से लेकर के यहां तक तुम पहुंचो, ठीक है। मैं इसको कर सकता हूं अच्छे से, रुक जाओ। यस, सुनो ध्यान से देखो, यहां पे ऐसा एक हॉरिजॉन्टल लाइन क्या है? रेफरेंस प्लेन है। उस रेफरेंस प्लेन से तुम यहां तक आओ 10 डिग्री, और ये प्लेन कौन सा है? पाई वाई प्लेन है, कटिंग एज के लॉन्ग नहीं है। अब मैं इस प्लेन को ले जा रहा हूं, कटिंग प्लेन बना रहा हूं, ये है कटिंग प्लेन। अब तुम जरा सोचो हॉरिजॉन्टल लाइन के बारे में, और फिर वहां से यहां तक का एंगल देखो, कम हो जाएगा ना। यस, क्लियर है? नहीं क्लियर है तो साफ साफ यहां भी दिख सकता है। यू नो ऐसा क्यों हो रहा है? वाई इज इट हैपनिंग? वाई बैक रेक एंगल इन दिस केस is more than this inclination angle? The reason is this rake face is not having only one slope, it has another slope in that direction. It is not having only one slope, it has another slope in that direction. Are you getting me? Yes dear students, are you getting me or not? You are getting me. What did you find here? What did you find here, dear students? I have shown you back rake angle and inclination angle at the same place. First time in the history of YouTube. Angles. Let me now write it. You look at angles. You look at angles. Angles measured with respect to and measured in. Angles measured with respect to and measured in. Look at back. Look at this back rake angle. Back rake angle is measured with respect to reference plane. back rectangle is measured with respect to reference plane. This is the back rectangle here, measured with respect to reference plane, but it is measured in pi y plane, but it is measured in pi y plane. Yes, here also same thing na, measured with respect to reference plane, but measured in, this angle is measured in pi y plane. Inclination angle is the brother of back rectangle. Inclination angle, which is here, this is the brother of back rectangle, but it is younger brother. क्या हो गया रामनिवास? पहले ट्रिक पेटेंट करवा लेते. कौन सा ट्रिक? सारा ट्रिक पेटेंटेड है, पता है ना रामनिवास? भूल के भी कॉपी करने की कोशिश मत करना, पकड़े जाओगे. Now, if you look at inclination angle, that is also same thing like brother of back rectangle. ये वाला back rectangle है, वो वाला inclination angle brother है, छोटा छोटा brother है. लेकिन अगर इस टूल की बात करें जो मैंने दिखाया है अभी, तो inclination angle कैसा है? Younger brother है. How is this inclination angle? This is younger brother. Inclination angle measured with respect to reference plane, but measured in which plane? Measured in which plane dear? Measured in which plane? फटाफट चैट बॉक्स में आओ. अरे बताओ, इंक्लिनेशन एंगल बैक रेक्टेंगल को ठीक है रेफरेंस प्लेन के रेस्पेक्ट में मेजर करते हो और पाई वाई दैट इज ट्रांसवर्स प्लेन में मेजर करते हो, लेकिन इंक्लिनेशन एंगल ठीक है रेफरेंस प्लेन के रेस्पेक्ट में मेजर करते हैं. किस प्लेन में मेजर करते हैं? इन व्हिच प्लेन डू वी मेजर इट? कम ऑन मैन. ओहो रामनिवास ग्रेट. अरे पहले ये तो बताओ किस प्लेन में मेजर करेंगे. अगर तुम बता दोगे तो मुझे ऐसा लगेगा कि मेरी मेहनत सफल हो चुकी है. वाओ वाओ उमंग कुमार पटेल, कटिंग प्लेन. ऑसम 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 ऑसम. तो चलो जरा अब यहां देखते हैं, थोड़ा अच्छे से देखते हैं जहां हमारे अच्छे अच्छे प्लेन्स बने हुए हैं. ये इंक्लिनेशन एंगल है ना? यस. नाउ आई विल शो यू द orthogonal rectangle. I'll show you the orthogonal rectangle and you are going to enjoy it, and this is a very important angle. Look at the tool. This is your tool. Yes, by the way Patel, how did you come to know about my classes? Till that you can answer me that question. Patel, how did you come to know about this class? How did you come to know about this class, Patel? And all of you tell me, who told you about my class? Z-axis. Here we have a plane like this, and this plane is your pi y plane. Answer me all of you. How did you know? How did you come to know about my classes? This plane is actually your pi x plane. Now let me show you one another plane. Let me show you one another plane. Which color to choose that will be visible to you and that will also look a bit different than this red. Let us choose this color. There is another plane here. Oh, this is not good because this will be similar to that of tool. So let me choose another color which even goes visible to you. Let's choose this color. Yes, it will work. There is this another plane. Look at this plane. Look at this plane now. This plane is the one which is perpendicular to the cutting edge. Exactly, this plane is exactly perpendicular to the cutting edge, but the plane which is behind, that is pi x, is not perpendicular to the cutting edge. Right, my dear? Now, there is a reference plane here. What is that reference plane? Let me show you the reference plane to all of you. Let me show you the reference plane to all of you. I am using green. I am sorry, I have no other option. I will show you the reference plane here. Let me take the shapes and let me choose this dark green color and then a straight line. There is this plane here. Yes. You know what plane is this? This plane is actually your reference plane. Yes, let me choose the pen now. This is your reference plane. Now, just now in ASA tool signature, I had discussed this angle. You look at this. What angle was this? Alpha S. Sideward inclination of this rake face. Yes, sideward inclination of this rake face measured with respect to what? Measured with respect to reference plane, but measured in which plane? Measured in pi x plane. Yes, that was the side rake angle. So where exactly is the side rake angle? Here. This is the reference plane. Reference plane is cutting both pi x and this plane. This plane is your orthogonal plane, perpendicular, exactly perpendicular to the cutting edge. Yes, reference plane is a horizontal plane which is cutting both the planes pi x and pi naught. And if you are measuring the sideward slope of the rake face, undoubtedly you will measure it with respect to reference plane. But if you measure that angle in a plane which is pi x, then you say that this angle is the side rake angle. Now, you know what is orthogonal rake angle? Orthogonal rake angle is also like side rake angle only. It is also giving you the sideward inclination of the rake face. It is also measured with respect to reference plane only. But my dear students, the orthogonal rake angle will be measured in what plane? It will be measured in orthogonal plane. Means you will measure the angle from the reference plane only. You will go to the rake face only, but the plane in which you will move during the measurement, that plane will be this orthogonal plane, because force will appear in the orthogonal plane. So my dear, that is going to be your angle. That is going to be your angle, my dear. This angle from reference plane up to rake face, but in which plane? In orthogonal plane. So this angle will be called as orthogonal rake angle. Now look at the diagram and tell me, out of side rake angle and orthogonal rake angle, which one is larger? Now tell me, out of side rake angle and orthogonal rake angle, which one is larger for this tool that I have shown? Out of side rake angle and orthogonal rake angle, which one is larger? Yes, it is very clearly visible. This side rake angle from here up to this is like smaller for this tool, and orthogonal rake angle is like larger. But both of them are brothers only. Both of them are brothers only. If you look at these angles here, if you look at these angles here, you look at these angles. If angles are there, they will be measured with respect to some plane and they will be measured in some plane. Yes, my dear. They will be measured with respect to some plane and they will be measured in some plane. Here we are measuring the two angles. One is side rake angle of ASA system, another one is orthogonal rake system. Sorry, orthogonal rake angle of ORS system. Both angles will be measured with respect to reference plane, but side rake angle will be measured with respect to pi x plane, and orthogonal rake angle will be measured with respect to, into pi o plane, that is orthogonal plane. Yes, did you get it? Did you understand what is orthogonal rake angle? Did you understand what is inclination angle? Inclination angle and back rake angle, both are brothers. Both of them are measured with respect to reference plane, but back rake angle is measured in pi y plane and inclination angle is measured in the pi c plane, which is exactly along the cutting edge. Then If you look at this, both side rectangle and orthogonal rectangle are brothers. Both side rectangle and orthogonal rectangles are brothers, but and both of them are being measured with respect to this reference plane only. But side rectangle is measured in this plane which is behind here, right? Pi x. But an orthogonal rectangle is measured in what plane? Orthogonal plane. That is the difference. And for force analysis, you will use the angles of ASA or you will use the angles of ORS. दोस्तों अगर समझ में आया, मजा आया, अच्छा लगा ये सारा कुछ, एक काम करो, शेयर दीज लेक्चर्स एज मच एज पॉसिबल, share these lectures as much as possible, share these lectures as much as possible with your friends and let them know that this is the first time in the history of YouTube inclination angle and orthogonal angle were discussed so perfectly. Yes, इसके पहले और कहीं नहीं, कुछ भी नहीं मिलेगा. हाँ, मेरे क्लासेस में मिलेगा, मेरे स्टूडेंट्स बता सकते हैं, कोई दूसरा इस पूरे यूनिवर्स में नहीं बता सकता इस तरीके से, स्पेशली कोचिंग इंडस्ट्री की बात करो तो. फिलहाल अच्छे से प्रिपरेशन करना है, खुद भी जान लो, सबको बता दो कि राजीव सर का रेफरल कोड जेम्स बॉन्ड वाला RK007 है, इसको यूज करके सब्सक्रिप्शन लेने का है. और यूट्यूब क्लासेस कब कब होंगी, स्पेशल क्लासेस फ्री वाली कब कब होंगी, उसकी जानकारी लेने के लिए एक टेलीग्राम ग्रुप है जिसका नाम है मेक आर्मी, MECHARMY. इस टेलीग्राम ग्रुप को ज्वाइन कर लो. टेलीग्राम में जाके सर्च करना मेक आर्मी, MECHARMY, है ना. टेलीग्राम ग्रुप को ज्वाइन करो, पता चलता रहेगा मैं फ्री स्पेशल क्लासेस कब लेता हूं, कैसे लेता हूं, यूट्यूब पे कब, स्पेशल पे कब. और ये रेफरल कोड जेम्स बॉन्ड वाला RK007. When did sir say legend of production is now live? Whether sir is watching these lectures, and say like pranam from my side to sir. And it's been so many days I didn't talk to sir. I'll talk to sir. Thank you all. Thank you very much for coming to this session. Tomorrow also be here at the right time. For now, you go and revise these two lectures. The first class, metal cutting part 1 and part 2. Yes? Go and Unacademy Accord. Yesterday I took this class. Today I took this class. Yesterday I took that part 1. Today I took this part 2. And tomorrow I will be having part 3. Tomorrow the day is going to be very much important. We are going to enter into the force analysis, and then day after tomorrow awesome questions will be discussed. Awesome questions. Here itself you will get full revision of manufacturing, and that too in this comprehensive way. I'll teach whole production over here. See you all. Bye bye. Good night. Don't forget to share. Don't forget to share. Don't forget to share. That's my kind request to all of you. Bye bye all. Good night. Hello. Someone is asking timing. Same timing. The time will be same. Daily 8:30 p.m. Daily 8:30 p.m. You have to be here on Unacademy Accord. Daily 8:30 p.m. You have to be here on Unacademy Accord. Yes? Someone asked the questions why again came live. Someone asked this why again came live. Guys, daily 8:30 p.m. Daily 8:30 p.m. I will be live on YouTube for all these coming days. Yes, you can utilize this series for your revision. Okay guys, so then see you. Bye.